What's going on, everybody? Welcome to the second video in the Kaggle Data Science Bowl 2017 kind of first pass video series. In this video, what we're going to be doing is just talking about handling the data. So a lot of tutorials that you're going to go through, including even some of the ones that I put out, a lot of times the data that you're dealing with is kind of pre-processed, pre-handled, already kind of pre-packaged information for you to just really quickly stuff it through some sort of classifier. In reality, data isn't typically in that form. So the first thing that we need to do, and even if it is in that form, the first thing we need to do is we need to look at the data. We need to understand how we can pull up this data and actually begin to look into the data, and then we can start kind of manipulating it however we need. So the first thing that we know is the case is, at least for now, the data that we have is CT scan data, and what it is each patient, basically, if you go to the files. So for example, I can actually bring up the files. So here are the files that I've got downloaded. Basically what you get is, this is me, I've already pre-processed some data there, but it's basically stage 1, and this is the stage 1 labels, and these are also this is also pre-processed, but then this is the sample submission, CSV, and all that. But basically stage 1 is what we're interested in. If you're following along in the kind of embedded kernel on Kaggle, you only have access to sample images. So you'd come here, and then as you can see, you've got, I don't know, 25 patients or something, I don't know, some amount of patients. So like these numbers here, these are your patient IDs. So this is a patient, and then bam, this is their scan. So you have some about 200 files that are scan data for that patient. So each of these is basically like a layer in that scan. But looking at this now, you'd probably have no clue that's what it was. You got to do a little bit of research to figure out, oh, okay, that's how it's working. Or if you're already maybe familiar with medical imaging, you just know, like, oh, it's 3D data. But this is all basically one scan. It's just each layer in that scan. So, and also just for the record, so you could put these together. And someone already has done that, so I'm really not going to spend time doing it. But if you go to the kernels and you go, really? Oh, okay, let's go through competition, then kernels. So the Data Science Bowl, and then go to, where is it? There we go. Kernels. So this pre-processing tutorial, you can click on that and just kind of see, or you can go through this kernel as well. But I'm just going to scroll on down. So right, here's a 3D rendering. And then here's another one, and another one, and another one, right? And these are created with these DICOM file scans. So anyway, that's the data that we're working with, but we still need to see it. We got to see it so we know what we're doing. So first of all, we need a few things. If you're doing this inside of the Kaggle kernel, you don't have to install anything. But if you're following along on your own machine, you have to do the following. I'm just going to write it into here, but let me make sure that's big enough for everybody to see. Maybe not that big, but that'll do. Something like that. I wish I could make this. I'm sure there's some way to make all this heading go away. I'm just not seeing it. It'd be nice if I could just... Anyway, pip install. We're going to need pandas. Pandas should automatically give you NumPy and Matplotlib, but just in case, pandas, NumPy, Matplotlib, Pydicom, and that should be it for now. I think the other stuff that we hit, I'll kind of talk about it. You could just throw in CV2. Yeah, just make sure you get at least those before we continue along. Okay, so I'm going to clear that out. And now I'm going to go ahead and begin importing DICOM, which will give us Pydicom. This is how we actually read the DICOM files. And then we're going to import OS. This is just going to let us kind of do directory operations. And then I'm going to import pandas as PD. Nice for data analysis. And really, pandas, I only really have one true use for pandas. That you could also probably just import CSV or something to read this data. I'm just going to use pandas, so if you are comfortable using just the straight up import CSV for what we're going to do, we're just going to use that to quickly grab the label for an ID. So yeah. Anyway, but later on, pandas, like if you're going to continue doing stuff to this data, like pandas is a useful library to use. But anyway, So now what we're going to do is specify the directory of everything we're using. If you are in the Kaggle direct or the Kaggle like online version, you would do something like this: data dir equals /input/sample images. If you're not, let me write this whole thing out for people that would be following along. Then I'll swap it. But basically, wherever your data directory is, wherever you save the files. So data dir there, we're going to say patients is just going to equal os.listdir, whatever the data dir is. So this will just have all of whatever's in that directory. So again, in sample images, it would be all these directories. And again, each of these directories is that patient's unique ID. So, okay, so that's our patients. And then we're going to say labels underscore df is equal to pd.read underscore csv. And we're going to read stage, or actually, sorry, if you're on Kaggle, it would be ./input/stage1 underscore labels.csv. And then you're going to say index underscore column equals 0. So that first column. Now, if you're on your own computer, such as me, it's wherever you installed these files. So, or downloaded rather, there's no installation for the data. Wherever you download the files to, they'll come in, zipped up and stuff, and you'll need to decompress, of course. But then it's wherever those are. Mine are in my X files. So X for me, and it's Kaggle underscore data, data science bowl 2017/stage1. Again, this isn't necessarily where your stage 1 will be. It's just where mine is. And then same thing down here. It's basically stage 1 labels. I think I actually just put this in the directory I'm working in. So my main drive is is just like a solid state drive, but I don't want to waste 140 gigabytes in my solid state drive, so I put this in one of my larger hard drives. Okay, just make sure wherever these files are, you're pointing to them. This should be one of the only major changes you'll have to make depending on where you are and what you're doing. And finally, we can do labels underscore df.head just to print the first 5 rows here. Sure enough, there we go. So this first patient is classified as having cancer, no cancer, no cancer, 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 and so on. So we know what the label is for quite a few of the patients. Some of the patients aren't contained in here. Okay, so that's what you're going to validate against later. So coming down here, once we have, we've got the patient IDs and stuff, but we still need to kind of see what we're dealing with. So what I'm going to do is I'm going to start a for loop, and for now we're just going to iterate through one thing. But later we're going to dive a little deeper, and we'll actually start pulling more than just one patient. But for now we're going to say for patient in patients to the first patient. So this will just be one patient. And we're going to say the label is equal to labels underscore df dot get value, and we want to get the value for basically the index, because so as we're iterating through patients, just remember what patients is. That's the listed directory of that data dir. So that's all these patient IDs. Now the patient ID is the first column in this stage 1 labels, so it's here. So we're saying we want to get values for the index that is the patient. So whatever that unique value is for our patient, that's the index we're interested in. And then we want the value for the cancer column. So that's the label for the patient. And now we're going to say what's the path to this patient. It's just going to be data dir. And you could be a good little Pythonista and use os.listdir, but os.path.join is the way you should be joining directories. But this is my first pass. This is the way I did it initially. It's just easier in my opinion. So I'm cheating a little bit, but anyways, we'll do that. Oops, I didn't actually mean to run that. Okay, so that's the actual path to this patient, and inside that path is all of those DICOM files. Okay, so I'm going to use 2 of the kind of one-liners that I grabbed from that top kernel. So I'm just literally going to copy and paste them into here. Copy. And just for the record, let me bring this, I guess, so everybody else can copy with me. So it was from Kaggle.com, competitions. There we go. Going to competitions. Kaggle, you're going slow, man. Data Science Bowl, kernels, full pre-processing tutorial. And what I want, these lines right here, fantastic. Copy, coming over here, paste. I couldn't have said it better myself. So we're going to take those. So what's happening here? Okay, we're using DICOM to read a file. What file are we reading? We're reading whatever the path is, which we said is the data dir of the patient. So the full patient path plus S. So what's S? Well, for S in os.lister path. And the path was the path to the patient. So this is going to get us every single DICOM file. Awesome. Now this next line kind of gives away one of the things about these DICOM files, but that's okay. It's sorting these DICOM files using this beautiful lambda function. And the way that it's doing is it's sorting it by x.imagePositionPatient 2. Okay, so what's happening here is X is referring to these DICOM files, and when you read in these DICOM files, they're not just like plain text. They actually have like attributes and stuff to them. So you'll see it in a moment, but just know that that's what it's doing. One of the attributes is the image position for that patient. So it tells you where that slice is supposed to be in order. So if you did do a 3D rendering, as they do in that kernel here, right, just a little bit below here is that 3D rendering, it's in proper order. So now what we're going to do is let's just out of curiosity, let's print the len of the slices and whatever the label is. We'll do that. Also, let's print slices 0. So this will tell us how many slices do we have, cancer or not, and then also this will just print out one of the DICOM files for us, just so we can see what we got here. So let's go ahead and run that. Just for the record, I haven't set it, but to run, it's Shift plus Enter if you're new to IPython notebooks. Enter is fine. You can just keep typing and it won't run anything. So this was the amount of slices. So we have 195 slices, and this patient does have cancer. And then coming down here, this is all that DICOM file. So it's got all this information here. So we have obviously a lot of stuff to work with. So now, what if we just modify this slightly? We're going to say for patient and patients 10, and then let's just do, let me think here. We don't need to print the DICOM file. Let's just print slices the label, and then also one of these, let's scroll down here. Where are you? Right. One thing to take note is rows and columns. So 512, 512. That's most likely telling us that this data is a 512 by 512 image. Okay, so if you're not familiar with convolutional neural networks or just neural networks in general and working with image data, that's a huge image. Now, also, it's not just a 512 by 512. Recall, this is a 3D scan. So this is actually 512 by 512 by 195. That is huge. So we already know right out of the gate, we're gonna have to really resize this information, and we're gonna have to deal with some loss of information when we do that. So the other thing I wanted to do is just let's get this information for a few patients. So we've got slices, and then also the other thing we could do is we're pretty sure it's 512 by 512, but we might want to make sure. And what we are going to look for is there's pixel data, and then there's also somewhere I think is the pixel array. I'm not like totally seeing it. Probably blind. Because I see pixel data, but I think what we're actually looking for is pixel underscore or pixel space array probably. I'm just not seeing it. I'm pretty sure we have a pixel array. Let me do that real quick. So if I come up here and do, let's say, slices 0 dot pixel underscore array, and let me just do dot shape. let's run that real quick. Yeah, so it does have the pixel array attribute. And I wonder, after this is done, I'll do pixel data, but this is also bringing up another issue. So as we run through this, we see, okay, everything is a 512 by 512, but there are different numbers of slices. So the depth is different of all of these scans. Again, if you know anything about any machine learning models, you know that the input data for most models, some models no, but let's say for a convolutional neural network, the input data must be all the same size. You can't have different size vectors. So that's not going to work. So again, not only do we have to resize this whole 512 by 512 and also resize 195, I mean, these numbers are way too big too. We also have a problem. Not all these images are the same size. So we know right away, we've got some work cut out for us. Also, I just want to run pixel data real quick. I'm curious. Live testing. Hey, you can tell me we don't have pixel data. Did I not just see pixel data? Let's do slices 0, patient 1. Okay, clearly I'm just a big dummy. Interesting, because you can reference these other elements because I've already referenced them. I'm not sure what I'm doing wrong there. Slices 0, dot, and I'm pretty sure it would just be all underscored. But let's do, how about pixel data, because that's how we reference this one. So dot pixel data. Oh, we probably made a huge mistake there. It's lagging out on me. Have we? I think it's game over at this point. It's probably way too much data to print out or something. I'm totally frozen. Yeah, whoops. Yay, data science. Okay, so this is going to probably take me a little bit to fix. I'm sorry, I led you guys down a bad path. Oh, come on, man. Oh, dear. I mean, okay, please, just let me edit this. I just want to edit it. Oh, what I really need to, let me just do this. Oh, okay, that's fine. That's fine. I just wanted to, okay, so lens slices. What was the other thing I was doing? The pixel array. So yeah, X, let's see, no. Yeah, we could do slices 0 dot pixel array, whoops, pixel array dot shape. So that's just an attribute of the DICOM file, I suppose. All right, that was fun. So, all right, so we know we've got that problem. The other question is, okay, how much data do we have? Well, we can quickly just do len pacientes. Just under 1,600. So, I mean, that's a lot of patients, but in terms of let's see, neural networks, that's not a lot. So there are a few things that we can do. One, we could, just quit. Or we can continue to at least see what happens. You might be the case that this is okay, especially if it is a really easy classification type of problem. This might not actually be that bad. I'm going to wager that's going to be a problem. But one thing to note is, like I was saying before, you'd be doing yourself a disservice if you don't go to the forums. So, or just fully read the competition. So two things I want to point out is when we go to the Data Science Bowl, if I go to tutorial, I think, you can find more data. It's somewhere. Here we go, the Luna 16 Grand Challenge. So there's another, I think, about 800, I think it's 888 new files. I can't remember for sure. Let's wait for it. I don't see it. It's here somewhere. I'm just going slow. Come on, man. Oh, let's go to data first. I bet maybe it'll be in here. Yeah, 888 CT scans. So in theory, as long as these are not the same CT scans, maybe you could throw them in. But then also, if you go to discussion and we scroll, here we go. Official external data thread. Boom. So this is going to be a really common thing that you're going to be able to see. Sure enough, you scroll down, sources, whee! Okay, so you could continue to build more and more data here. Now, most of these data sets are not huge, so it's still probably not going to be the case that you're going to get to 100,000 samples, but if you could, now your neural network's going to be cooking. Anyway, the show must go on. So I think what I'm going to do is I'm going to leave it here, and then in the next tutorial we're going to start talking about using Matplotlib to visualize this, because right now we're still kind of dealing in very abstract terms. We're iterating through, we're getting single numbers, but we still haven't really seen the data, right? We've seen attributes of data. So in the next tutorial we're going to actually really see the data. We're going to look at it in Matplotlib, and it should be absolutely clear to us within short order that whether or not we're actually looking at lung scans or not. So that's what you guys have to look forward to. Questions, comments, concerns, whatever, leave them below. Otherwise, I'll see you in the next video.